Hello everyone, I'm Zhang Fangwei from Beijing University of Posts and Telecommunications. In our previous lectures, we explored how new quality productive forces through technological innovation have brought profound transformations in areas like intelligent connectivity, smart manufacturing, advanced materials, and clean energy, thereby optimizing and enhancing existing capacities. However, the connotation of new quality productive forces goes far beyond this. Another equally important path is cultivating emerging industries and strategically developing future industries, thus creating entirely new drivers of growth. This brings us to today's topic, new frontiers of sea, air, and space. This is a key new domain and a powerful growth engine driven by new quality productive forces. It provides entirely new resources, space, and possibilities for economic and social development, serving as a crucial driver of high-quality development. Today, we will examine this grand vision through four major cases: China's manned deep-sea submersibles, deep-sea smart aquaculture, the Beidou navigation satellite system, and the low-altitude economy. First, let's focus on the ocean. The birth of China's manned deep-sea submersible Jiaolong, named after a mythical sea dragon, marks a significant milestone in China's deep-sea exploration. It successfully dived to a depth of over 7,000 meters, demonstrating China's ability to conduct deep-sea scientific research and resource exploration in 99.8% of the world's ocean floor. But this is only the beginning. The most important contribution of Jiaolong lies in the fact that it initiated and validated a sustainable, rapidly iterative model of innovation. The goal was not just to achieve single-point technological breakthroughs, but to build a systemic innovation capability that could self-evolve and continuously accelerate. Following the success of Jiaolong, Shenhai Yongshi, meaning deep sea warrior, could reach a depth of 4,500 meters, and it was tasked with scientific exploration, engineering application, search and salvage, and emergency response. In addition, the localization rate of this submersible reached 95%, which greatly improved the cost effectiveness of scientific research. Then, 奋斗者, which means striver, set a national record by diving to a depth of 10,909 meters and Mariana Trench. So, what exactly has our great effort in deep-sea exploration brought us? On the one hand, it has given us an entirely new understanding of strategic resources on Earth. Through these submersibles, Chinese scientists have discovered new life communities and genetic resources in multiple hydrothermal vent fields in the ocean, opening up new frontiers for pharmaceutical research and development. At the same time, precise exploration and sampling of polymetallic nodules and cobalt-rich crusts have provided first-hand information for the sustainable utilization of strategic mineral resources in the future. On the other hand, it has driven the advancement of high-end manufacturing. The development of deep-sea submersibles is the ultimate test of a nation's manufacturing and materials science. From the titanium alloy manned cabin that is lightweight and has the strength to withstand the immensely high pressure in the abyss, to the high-speed underwater acoustic communication system that could transfer sounds, images, letters, and other signals instantaneously between the carrier and the sub, and the dexterous and powerful robotic arms. These technologies are now spilling over into broader fields such as shipbuilding, marine engineering, equipment, precision instruments, and even artificial intelligence, collectively elevating the level of China's smart manufacturing. If manned deep-sea submersibles represent China's capability to explore the unknown depths of the ocean, then another manifestation of new quality productive forces in the marine field is the development of an entirely new industrial model, deep-sea smart aquaculture. Let's look at Guoxingwan as one example. As the world's first 100,000-ton intelligent aquaculture ship, it's less of a traditional fishing boat and more of a mobile fish farm. It has moved the traditional aquaculture from coastal waters to deep sea, where water quality is better and the space is broader. The ship houses 15 breeding cabins with a total water holding capacity of nearly 90,000 cubic meters. Centralized control and the real-time monitoring of water, oxygen, light, and the feeding in the breeding tanks are carried out by 2,108 measuring and control points on the ship. The fish breeding density in the tanks can be 4 to 6 times that in traditional aquaculture cages, and the breeding cycle can be shortened by more than a quarter. This model not only frees traditional fisheries from the constraints of nearshore environments and the threats of natural disasters such as typhoons, but also serves as a good example of the deep integration of marine engineering, artificial intelligence, and biotechnology. It represents an innovative exploration of transforming marine aquaculture from a traditional agriculture-based model to a modern industrialized mode of protection. Now, let's turn to the field of aerospace, the Beidou Navigation Satellite System, or BDS. Is without doubt one of China's most grand scientific and technological projects of the past 2 decades. It has not only achieved full-scale global coverage and provided the world with a high-precision alternative independent of GPS, but more importantly, it has taken on an entirely new role, serving as the digital spatio-temporal foundation that drives the development of new quality productive forces. Today, the Beidou Plus model is integrating with various industries at unprecedented depth and breadth. At the Ningbo Zhoushan port, one of the world's busiest ports, high-precision positioning powered by BDS enables intelligent guided vehicles to operate continuously 24 hours a day, shuttling between storage yards and decks. With centimeter-level positioning accuracy and optimized driving routes, the port's overall operational efficiency has been increased, while significantly reducing labor costs and safety risks. In the vast cotton fields of Xinjiang, unmanned seeders equipped with BDS have been fully deployed. They complete mulching, seeding, and soil covering in a single operation with a straight line area of no more than 2 centimeters per kilometer. Compared with the traditional sowing methods, this approach not only saves cotton seeds, but also improves land use efficiency and facilitates fully mechanized field management and harvesting as the cotton plants mature. Drones, based on BDS positioning and the remote sensing data, analyze the growth of the cotton plants and spray only the areas that require additional nutrients. When the cotton harvest season arrives, harvesters equipped with BDS can precisely align with the cotton rows for highly efficient picking. This has improved the cotton picking efficiency by 3%. Similar examples abound. Overall, BDS has become an indispensable infrastructure in the digital economy era, like water and electricity, empowering industries and profoundly changing people's lives and the way they work. Finally, let's explore the low-altitude economy. It refers to the economic activities surrounding both manned and unmanned aircraft, typically operating in airspace below 1,000 meters and extending up to 3,000 meters as needed. In 2024, for the first time, it was included in the Chinese government's work report, marking its rise as a national strategic emerging industry. The first scenario is drone delivery. Imagine this. After you order a cup of coffee on your phone, a small drone takes off and delivers it to your designated drop-off point within 15 minutes. This kind of service has already been rolled out as a regular operation in Shenzhen, greatly improving delivery efficiency and helping ease ground traffic congestion during peak hours. The second scenario is urban air mobility. Chinese companies are stepping up efforts to commercially operate electric vertical takeoff and landing aircraft, or eVTOL aircraft. China's EH216S is the world's first and only eVTOL aircraft to secure all 4 certifications required for commercial operation. Having completed tens of thousands of safe flights in many cities, it's already driving real-world applications in passenger transport, aerial tourism, logistics, and emergency medical services. We can say the futuristic vision of gliding above traffic in an autonomous flying taxi is fast becoming a reality. What's more, the eVTOL aircraft named Prosperity, developed by a Chinese high-tech company, has completed its world's first intercity electric air taxi demonstration flight between Shenzhen and Zhuhai, reducing a ground journey of 3 hours to just 20 minutes. With a maximum range of 250 kilometers, it's capable of carrying 5 people with a cruise speed of up to 200 kilometers per hour. Meanwhile, a Chinese electric vehicle maker has developed a land aircraft carrier, a flying car made up of 2 parts, a ground module and an air module. The ground module operates as an electric vehicle, while the air module is an eVTOL, a flying craft with 6 propellers that can fold up and be stored when not in use. Thus, it's perfectly suited to meet the needs of intercity commuting with modular flying vehicles. Today, a growing number of cities like Shenzhen, Guangzhou, Hefei, Zhuhai, and Wuhu are actively opening up low-altitude airspace, building takeoff and landing sites, introducing subsidy policies, and formulating local regulations for the development of the low-altitude economy. A new trillion-level industrial chain covering aircraft manufacturing, aerial operations, ground support, and data services is rapidly taking shape in China. So, our journey today has taken us from the deepest oceans to the frontiers of air and space. Manned deep-sea submersibles demonstrate our ability to achieve pioneering technological breakthroughs through collaborative innovation in extreme environments. Deep-sea smart aquaculture shows how digital and intelligent farming equipment is injecting new vitality into marine aquaculture. The Beidou navigation satellite system demonstrates the ability to translate cutting-edge space technology into inclusive digital infrastructure that empowers the whole society. And the low-altitude economy represents our capacity to open up entirely new industrial frontiers for the future and turn science fiction scenarios into reality. They all begin with technological innovation, and through combined effect of industrial integration, market demand, and policy support, have evolved into strong and sustainable new drivers of economic growth. This is precisely the core logic of new quality productive forces. Crucially, this story is not unfolding in isolation. The technologies behind manned deep-sea submersibles like Jiaolong are evolving into platforms for international scientific collaboration in the deep seas. Guoxing-1 intelligent aquaculture ship has filled a gap in the field of industrialized fisheries worldwide. Beidou services now cover more than 200 countries and regions. And the pioneers of the low-altitude economy are actively working with international aviation authorities, helping shape the global framework for the skies of tomorrow. Finally, let's conclude on a deeper level. What we have discussed today isn't just a story about technology and economy. It is, above all, an invitation to look up at the sky, to gaze into the depths of our oceans, and to imagine a future where boundaries of possibility are defined not by gravity, but by our shared ambition. Yes, it is about exploring new frontiers of growth, but at its core, it's about expanding the very frontiers of human potential itself. Thank you for watching.